Hi, the purpose of this video is to discuss what could be causing an actuator or an air cylinder to be losing speed or losing force. Of course, being an air actuator, it is powered by air, so we need to look at the air pressure. Are we getting enough air pressure? And the first thing would be the source of that air is coming from a compressor, and is the compressor coping with the system demands? Not only the demand of your machine but also of the factory. It could be that new machines have been added, new equipment, and that is using more air and the compressor is struggling to keep up or cope. So this is one consideration we need to look at. The next consideration would be obviously that the air has to be filtered and treated, and where it's filtered, of course, there's an element that could get clogged. Okay, here we have a typical installation with a filter regulator, a lubricator going through a valve to operate the air cylinder. The air cylinder we are showing here has a flow control at each end to control the speed. If the cylinder is slowed down, it could be that we're not getting enough pressure through the filter regulator. In a typical application, say set up for 80 psi or 5.5 bar, when this actuator actually starts to move, you should see a deflection in the needle on the gauge of only 3 to 5 psi or 20 to 35 kPa. If the deflection is greater than that, it means that we're showing signs that there is some contamination building up in the filter element, or the regulator is also contaminated. When the cylinder is actuating, you see a very large movement in the needle, say up to 10 psi or 70 kPa. Then there's obviously a restriction. This should not be happening. We should only be getting about 5 psi or 30 kPa maximum fluctuation of the needle. That means we need to first of all start looking at the filter and changing the element. So the first thing would be to change the filter element. If you're still having a problem with wild fluctuation of pressure, then it's likely to be something else. The other thing to consider would be that the piston in the regulator is not moving freely due to contaminants, so that would be something to consider as well. Is that the lubricator may have run out of oil, and therefore we're not getting lubrication through to the air cylinder. The piston seals have got more friction, and therefore the cylinder has slowed down. We've been talking about how contamination can affect a filter. It can also affect the flow controls that we have attached to the cylinder. Contamination can build up around the needles and therefore reduce the flow path, and therefore cause a reduction in the airflow and therefore the cylinder movement. And sometimes that can be corrected just by readjusting the needle on the flow control. An air cylinder is designed to take a certain amount of side force or side loading, up to 15% of the thrust of the cylinder, depending on stroke. But over a period of time we can get wear and tear of componentry, and we can get misalignment, where an excessive side force is now applied to the piston rod, and this can cause binding around the neck area, and which can also cause wear in this area as well. Here we have a diagram showing what the effects of misalignment can be on an air cylinder. In this case, we've got air coming in and retracting the cylinder. Because of misalignment, we're going to get a high wear rate in this area, causing the seals to eventually leak, and we're going to get a loss of pressure and a loss of force. Another thing to consider is piston seal wear. In this case, we've got air coming in, retracting the cylinder, and over a period of time, if the piston seals wear, we will get bypass, and once again resulting in loss of pressure and loss of force.